Hello and welcome back. We are looking at Math with Business Applications, Chapter 5, and Parts 4 through 7 in your course supplement. This is still a part of Unit 2, which is the basics of algebra. Today we're going to be taking a look at Chapter 5 in your text, Section 1. So once again, this is Basics of Algebra, Chapter 5, Section 1. We're going to be working on solving equations. And before we can start solving equations, there's a couple of things we need to review. The first is the idea of inverse operations. Now, there are 4 basic operations in mathematics: addition, subtraction, multiplication, and division. We can also include exponents such as squares. Each of these have an inverse, that is an operation that undoes or reverses the named operation. So here you have a chart. For addition, the inverse operation is subtraction. For subtraction, the inverse operation is addition. For multiplication, you can undo or reverse multiplication with division. And for division, you can invert or undo that operation with multiplication. Similarly, if you have exponents at all, if you have squares, they can be done with square roots, and likewise square roots can be undone by squaring it. We likely won't see that one, but you may see squares being undone with a square root. The second part of solving an equation that is of the utmost importance is the idea of the properties of equality. Now, the properties of equality come into play because when you are solving an equation using an operation, that is addition, subtraction, multiplication, division, or even squaring, that operation must be applied to both sides of your equation. That is the left side of the equal sign and the right side of the equal sign. This is what we do to maintain balance. It keeps the values on both sides of your equal sign the same. I like to think of it like if you've got 2 kids and their bedrooms are split by a hallway, 2 kids lucky enough to have their own bedrooms, and the hallway is in the middle. If you add something to kid number 1's room, you better add the same value to kids number 2. What do I mean by that? Well, if I put a television in Corey's room, I better be willing to put a television in Matthew's room. Because if I don't, then the balance is upset. And as a parent, that could be disastrous, right? Similarly, if I take something out of Corey's room, I best be willing to take something of equal importance or value out of Matthew's room, or it's going to be unfair and I'm going to upset the balance. So if you can think of the equal sign like that hallway separating the rooms, then you understand what I mean by whatever you do to one side, you have to do to the other. Okay, there are 4 main properties of equality. It's not important that you know them all by heart. It's just important that you understand what they say. So the first one is the property of the addition property of equality, which basically says if 2 things are said to be equal, you can add to both of them and you still get equal results. Similarly for subtraction, if 2 things are equal and you subtract from both of those things, the resulting values are still equal. Multiplication is the same, division is the same. We are saying the same thing for all of these 4 properties of equality. That is, if they start out the same and you apply the operator, they have to end the same as well. All right. So some very basic equations are where we're going to start. And as we begin this, I remind you that there are varying levels of ability here. If this is something you are already familiar with, that is fine. You are welcome to just plug right along. If you need some review on algebra, I strongly suggest that you write these down and go through them with me. All right, so my first one is x plus 4 is equal to 15. You will see that there are 2 sides to this equation. There is the left side and the right side. So I'm going to take my yellow pen here and I'm going to draw a line down the equal sign. On the left side of the equal sign, I have x plus 4. On the right side of the equal sign, I have 15. These two values are currently equal, and I would like to determine the value of x. Now, since x is being added to 4, I am going to undo that addition by subtracting 4 from the left side. And as we just got done saying, I must also then subtract 4 from the right side. This gives me, on the left side, I had x plus 4, and I'm taking that 4 away, so I'm going to be left with x. On the right side, I have 15 minus 4, which now leaves me with 11. Because we started out equal and I took 4 away from both of them, my resulting answer of x has to be 11 should now be equal. I can and should check these. The check basically consists of taking that value of 11 and putting it in for the x. So if 11 is my x, then x plus 4 should equal 15. Does x plus 4 equal 15? Why, yes, it does. So this checks, and I am now certain that my x value has to be 11. All right, second example. I'm still going to write that line down the equal sign. So I have my left side and my right side. On the left side, I have x minus 15.4 is equal to 4.3. So since I'm solving for x, I'm going to undo the minus 15.4 by adding 15.4. And if I add that to the left side, I must also add that to the right side. This leaves me with x. I had a minus 15.4 and I added 15.4. So those will zero out and it will have to be equal to 4.3 plus 15.4, which is 19.7. Now what I want to do is check that by putting 19.7 in where x was. So instead of x minus 15.4, I'm now going to use 19.7 minus the 15.4. And I'm going to check and see, does that equal 4.3? Well, if I plug this into a calculator and subtract, I do get 4.3. So this tells me that it is indeed correct. And I can put a red box around this to show that I am done. All right, here are a couple more. Here I have 0.9x is equal to a negative 0.45. I've got a left side and a right side to this equation. On the left side, I have the 0.9x. Now, some of you may not be familiar, but when you don't have anything in between, I can call that multiplication. So in order to undo the multiplication, I want to divide by 0.9 on the left side. And because this is a property of equality, I must also divide by 0.9 on the right side. Divide by 0.9 on the right side. Now, if I have 0.9 and I divide by 0.9, that's actually not going to give me 0. This is why sometimes it gets confusing. If I have 0.9 and I divide by 0.9, I'm left with 1x. So I have 1x is equal to, now, negative 0.45 divided by 0.9. I'm going to pull out my calculator because, you know, sometimes with decimals. Negative 0.45 divided by 0.9, and I get a negative 0.5. It's interesting here. Remember your negatives, so negative divided by a positive should still be negative. And it's also worth mentioning that the 1 here is not needed. 1x is just the same as x, so my x would be a negative 0.5. All right, now, if you're not sure, You can always check. So when I check this, I'm going to do 0.9, and I'm going to multiply that by what I think my x is, a negative 0.5. And will I get a negative 0.45? And the fact is that I do. Negative 0.45. And so this does indeed check. And I can put my red box around there because I'm certain of my answer. All right, what about the fourth example? The fourth example shows x over a negative 5 dividing that, or I'm sorry, x over a negative 5 equal to a 1.25. So if I draw my line down the equal sign again, I see that I have on the left side x divided by a negative 5, and on the right side I have a 1.25. So the opposite of dividing by a negative 5 is the opposite of division is multiplication. So I'm going to multiply by a negative 5. And if I do that on the left side, I also need to do that on the right side. Now on the left side, it's a little bit awkward because this one looks like a fraction and this one does not. So I'm just going to do the easy fractions sort of trick here, which is to write this as negative 5 over 1. Negative 5 over 1, there we go, times x over negative 5. And then we should be familiar enough here to see that what's going to happen is our negative 5s here are going to cancel. So I'm going to have a negative 5 canceling with that negative 5. That's just going to leave me with an x over 1 equal to a 1.25 times the negative 5, which is going to give me a negative 6.75, I think. 6.25. A negative 6.25. Now, x over 1 is just the same as x, so x is equal to a negative 6.25. Watching my signs, I've got a positive times a negative, so yes, indeed, that should be negative. Now, you can check again because it's decimals maybe and you're not quite sure. So we're going to do a check here, and we're going to do a negative 6.25, and we're going to divide that by negative 5. And we're going to see if we do get 1.25. So negative 6.25 divide by negative 5. And yes, I do get 1.25. So once I have checked that, I can be sure, and I can put a red box around it to show that I am right. All right. So what do we need to watch out for? Well, one of the things I'm going to ask that you be careful of is to make sure that you're using the right inverse operation. If we have 5x divided by 8, do we subtract 5? It's important to know what operation is showing. Here we're solving for the x, and that x is being multiplied by 5. So in order to undo the multiplication, we want to divide. All right? The common mistake here is to try and subtract. And we don't want to subtract. That's not the inverse of multiplication. All right. It's okay, Romy. So what do we do when there are multiple steps? All right. So when there are multiple steps, here we have an example where we're solving for the letter R. What's going on here? So we're solving for the letter R. Okay, left side, right side. You can see on the left side, I have a 7R minus 5, and on the right side, I have a 51. Now, the complication here is that not only are we subtracting 5 from the R, but we're also multiplying it by 7. So I need to take care of two operations. I need to undo the multiplication, and I need to undo the subtraction. Which do we undo first? Well, it took me a while to figure this out, but you guys remember PEMDAS? Do you remember, please excuse my dear Aunt Sally? That's the order of operations. When we're evaluating things, we do the order of operations. When we're solving things, we do the order of operations in reverse because we're working our way backwards. They've like dropped all the clues here and we're solving for R. So we need to start at addition and subtraction. So what I'm going to do is the first thing I'm going to do here, I want my green one, there we go, is I'm going to add 5 to both sides. Right? Between multiplication and subtraction, I start from the bottom up, so subtraction gets taken care of first. And that gives me 7R is equal to 56. Now here I have 7 times R. So to undo that multiplication, I want to do division. So I'm going to divide by 7 on both sides. I'm showing the division here as a fraction. It doesn't matter. I could have written out divide by 7. That would have been fine too. The fraction is just a little faster when I'm notating it. That's all. Now that I have 7R divided by 7, this is 1R equal to 56 divided by 7, which is 8. 1R is the same as R, so R is equal to 8. If I want to, I can check this to be sure I'm right. So when I check it, I put 7 times 8 minus 5. That's 56 minus 5, which is indeed 51, and it checks. So I know I have the correct answer, and I'm confident that my R value is 8. Here we have a second type of problem where we have a left side and a right side again, but the hard part on this guy is that I have the variables on both sides. So I need to get both of these variables on the same side. I can move these 5Qs over to the right side, or I can move these negative 2Qs over to the left side. Which one is right? Both of them. Both of them will work. As long as you're following this idea of balance, it doesn't matter which one you move. If I want to move the 5Q, right? If I want to move this 5Q, it's technically positive. So I would need to subtract 5Q from both sides. Now, there's nothing wrong with that, but I know when I subtract, I tend to make mistakes. So I look to see if there's something that I could add. And since the 2Q here is negative, in order to move or switch this 2Q over, I would need to add 2Q. I do better with addition. So I'm going to add 2Q to the left side. And as we do that, we have said that whatever we do to the one side, we have to do to the other. So in the idea of balance, I need to add 2Q to the right side. This gives me 5Q plus 2Qs, which is 7Qs, plus 12 is equal to 4, right? Because I have minus 2Q plus 2Q. Now this problem is very similar to the one we just did. So I've got a Q, and I'm adding to it, and I'm multiplying. We've already said it's order of operations in reverse. So I'm going to subtract the 12 from both sides. This leaves me with 7Q equals a negative 8. Now that's 7 times Q. So I'm going to undo the multiplication by dividing. And again, I'm writing it as a fraction, and that's perfectly fine. 7Q over 7, the 7s will cancel, leaving me with 1Q is equal to, and I'm going to leave this as a negative 8 over 7. I don't know what 8 over 7 is. I mean, I could do it in a calculator and get a decimal, but that decimal is going to be long because 7 is not a good number to divide by. So I'm going to get a long, complicated fraction. So instead of doing that, I'm going to leave it in the algebraic notation, which is 8 over 7. because that tells people what to plug into the calculator, and it's actually shorter than writing out the decimal. So I'm going to leave it in fraction form as a negative 8 over 7. Q has to be a negative 8 over 7. Now I can check this, and this, because I have a fraction, is easiest to check. If you have a fraction bar or a fraction, negative 8 over 7 plus 12, will that equal a negative 2? 8 over 7 plus 4. So that's going to be a negative 40 over 7 plus 12 is going to be 84 over 7. So that's a negative, nope, it's a positive 44 over 7. This guy is going to be a negative 16 over 7 plus 28. Oh, I forgot the negative. So that's going to be a positive 16 over 7 plus 28 over 7, which is again 44 over 7. Aha! And it checks. So yes, this is correct. And I have that right. Great. So we've got the two-step equation, and then we've got Q's on same variable on both sides. What's next? All right, so next we've got a fraction thrown in. Yeah, so there's a couple of ways to do this one. Let's see what we can do here. All right, so just as a reminder, left side, right side. Ta-da! I've got a 2/3 b plus 3 is equal to a negative 15. I'm going to say the b here, I'm multiplying by 2/3 and I'm adding 3. Order of operations, if I do that, please excuse my dear Aunt Sally. If I'm solving, I do this backwards. So I want to undo the addition by subtracting 3 from both sides. That will give me a 2/3 b is equal to a negative 18. Now, 2/3 b times, that's 2/3 times b. There's like three different ways we can go from here. Here's what I think is the easiest. Since I have 2/3 b, that's a 2 divided by 3. So I'm going to multiply. I'm going to use my order of operations here, and I'm going to multiply this side by 3, and that means I have to multiply this side by 3. That's going to be a 3 over 1 in fraction form. So those will cancel, and I'm left with 2b is equal to a negative 54. 18 times 3, 36, 54. Yep. And then I have 2 times b, so I'm going to divide by 2, which leaves me with 1b is equal to a negative 27, or b would be equal to a negative 27. I can now check this by saying 2/3 of a negative 27 plus 3, which is going to be a negative 18 plus 3, which is a negative 15. That's what I was supposed to get. So, yep, this guy checks. And I am good to go there. Okay. If you want to know the other couple of ways, send me an email. Or, even better yet, book an appointment on Calendly. All right, next problem. Holy cats. Okay, so sometimes we get these kinds and they're completely overwhelming. And what we want to do when we get these is sort of clean up the left side and the right side first. Remember I talked about them like rooms? So I'm going to put my left side and my right side in here. Left side, right side. And the first thing I want to look at is this left side. Is there anything that I can do to sort of clean this up? Is there anything that can happen? Well, I've got 9y here, and I've got minus y here. That's technically a 1y. So if I have 9y minus 1y, that's going to be 8y. So I have 8y minus 8. Okay, now I'm going to take a look. I should mention, I can't do anything more with that. One has a y in it, one doesn't. So it's not like I can combine those. That needs to stay 8y minus 8. On the right side, I can distribute. I've got a 2, so I can do 2 times the 2y. That's going to be 4y. And I can do 2 times the 4. That's a plus 8. All right, that's great. Now I've got a little bit cleaner left side and a little bit cleaner right side. This goes back to a problem we did on the last page. I've got y's on the left and y's on the right. I can move the 8y by subtracting it. But I don't have enough here to do 4 minus 8. I don't have enough y's on this side to take 8 away. Now, if I have to, I can. That'll give me negatives. But I could just as easily subtract the 4y. And I've got enough on this side to cover that. So I'm going to subtract 4y. And if I do that from the right side, I must also do that from the left side. That's going to leave me with 4y minus 8 is equal to 8. All right, now 4y minus 8 equal to 8. I've got subtraction and I've got multiplication. So I'm going to add 8 to the left side. That means I must, for equality, add 8 to the right side. This gives me 4y is equal to 16. Now that's 4 times y. So I'm going to divide by 4 on both sides of this equation. That will leave me with 1y is equal to 16 divided by 4 is 4. So y would be equal to 4. And now I'm going to check real quick. This is how you speed check. We're putting the 4 in for the y. So we've got 9 times 4, which is 36, minus 8, minus 1 times y, or 4. So that's going to be 24. And then on the other side, we're going to have 2 times 2 times 4, which is 8 plus 4. 8 plus 4 is 12, so we're going to have 2 times 12, which is indeed 24. This checks, and I can be sure that what I have here is the correct answer. Fantastic. Okay. Now, I would like to assure you that for the most part, this last example is as difficult as we're getting in terms of algebraic equations to solve, with one exception. And I'm going to go through 2 examples of that exception on the next slide. So, what we have here is equations with a lot of fractions. All right, so here we have 2x over 9 plus 1 is equal to 3/5 times the quantity 4x minus 5. What we want to do in order to solve this is to eliminate fractions. I refer to this as unyucking sometimes, because for the most part, you look at this problem and you think, oh, good God, she put fractions in it, which I did. It's part of one of the outcomes of this course is that you're able to solve equations with fractions. So here we go. In order to complete this problem, we need to be able to identify the least common denominator and each of the terms in this equation. So let's start. This equation has 2 denominators of 9 and 5. That means that the common denominator for 9 and 5 would be 45. So the LCD for this particular problem is 9 times 5, or 45. Now, how many terms are there? Well, there are technically 3 terms in this particular problem. The first term is the collection of 2x over 9. The variables and the coefficients together make a term. So we have one term with the 2x over 9. We have a second term with the plus 1. And both of those are on the left side of the equation. On the right side of the equation, it can be somewhat confusing, but right now, as it stands, all of that is one term. The parentheses put the 4x minus 3 together, so we do not consider it to be 2 terms. Once I've distributed the 3/5, then I would have 2 terms, but as it stands with the distribution, we would consider it 1 term. So what we're going to do is we're going to multiply each of these terms by that LCD of 45. Here's what it looks like. I'm going to put 45, bright pink, in front of the 2x over 9. I'm going to put 45 in front of that 1. And then on the other side of the equal sign, I'm going to put 45 in front of that great big old mess. All right? Why did I do that? I'm essentially distributing the 45 to each one of the terms on the left side and on the right side. Since there were 2 terms on the left side, I had to write it down twice. And since there was only 1 term on the right side, I only needed to write it down once. Now, once we've done that distribution, what we want to do is cancel the 45 with the denominators where they exist. So I'm going to take that 45 in the first term and divide it or cancel it with the 9. That's going to leave me with a 5 times 2x. I'm going to take the 45 times the 1. There was not a denominator, so it's going to stay the same. On the right side of the equation, I will have 45 canceling with the 5 in the denominator there. And 45 canceled with a 5 will leave me 9. So I now have 5 times 2x plus 45 times 1 equal to 9 times the quantity 3 times 4x minus 3. Now I want to distribute what I can. So that's going to leave me with 10x plus 45 is equal to 27 times 4x minus 3. I do the 9 times 3 first. It's all multiplication. We know from some of our earlier properties that the order won't matter, so I prefer to do 9 times 3 and then multiply that by the 4x minus 3. If you're following the parentheses, you could distribute the 3 first to get 12x minus 9, but the order we do this in doesn't matter because multiplication can be done in any order. All right, so now I'm going to distribute that 27. So I have 10x plus 45 is equal to 108 minus 81. I have 10x on the left side and 108x on the right. I can subtract the 10x from both sides. I have enough in the 108x to cover it, or I can subtract the 108x from both sides. I'll just get a negative number, which is fine. I just know where my weaknesses lie. So when we do this, you should end up with 126 is equal to 98x. I did 2 steps in one there. Not only did I subtract 10x from both sides, I also added the 81 to both sides, and I did them in the same step. So that's where those numbers suddenly came from. Now I want to divide both sides by 98 and reduce. 126 over 98 turns out to be 9/7 in reduced form. You can do the reductions on your calculator, or you can divide both sides by 14. I believe both the numerator and the denominator are divisible by 14. Okay, that was a lot. Can we do a second example? Let's try a second one. All right, here comes the second one. We have 2/5 x plus 4/3 is equal to 2 minus the 1/6 x. Now, we need to identify the LCD and know how many terms there are. because however many terms there are, that's how many things we will multiply by the LCD. If I look at this equation, there are 2 terms on the left side. The 2/5 x is one term. The 4/3 is a second term. And on the right side, there is also 2 terms. I have the 2 as a constant term minus 1/6 x as a second term. Now, that gives me 2 terms on the left side and 2 terms on the right side. Now I need to determine the LCD. I have the numbers 5, 3, and 6. So I'm looking for the lowest number that all of those, a 5, a 3, and a 6, will go into. So how do you find the LCD? What I do is I take the 2 largest numbers, in this case the 5 and the 6, and I multiply them together. I get a 30. And then I check, will 3 go into 30? Sure. So 30 will work as a common denominator for 5, 3, and 6. You can do this with any 2 numbers. I tend to choose the largest as it works faster. Any 2 will work, but the largest work faster. All right, so I'm going to multiply each one of these 4 terms by that LCD of 30. This is going to give me 30 times 2/5 x plus 30 times 4/3 equal to 30 times 2 minus 30 times 1/6 x. And once I have multiplied all of those out, then I want to cancel with the denominators. So I'm going to do 30 divided by 5, which is 6, but I still have the 2x to multiply by. I'm going to do 30 divided by 3, that's 10, but I still have the 4 to multiply there. 30 times 2 I could do, or I could leave it. And then minus 30 times the 1/6. The 30 will cancel with the 6, but I haven't dealt with the 1x. So this will look like 6 times 2x plus 10 times 4 is equal to 30 times 2 minus 5 times the 1x. This shows the result of all of that canceling. Once I've done the canceling, notice all of the fractions are gone. I have no more fractions in this particular problem, and I can just do some simple multiplication. 6 times 2x is 12x, 10 times 4 is 40, 30 times 2 is 60, 5 times 1x is 5x. Now, this particular problem is very similar to ones we've done several times before. I have x's on both sides. I can take the 12x and move it over to the right side, in which case I would need to subtract it to move it. Or I can take the minus 5x and add 5 to both sides in order to move that minus 5x over to the left side. I'm going to choose to add 5x to both sides because I'm better with addition. So I'm going to add 5x to both sides. And I'm also going to subtract 40 from both sides. That should leave us with 17x is equal to 20. Now, in order to find x, I just need to divide both sides by 17. And this gives us that x is equal to 20 divided by 17. Once again, I'm going to leave this just in that algebraic statement. I don't know what 20 divided by 17 is. It's some decimal, and somebody can plug that into their calculator without me telling them. So most of the time, we'll be leaving these as improper or just fractions. Improper fractions or fractions, right? Okay, so to summarize, steps to solving. When given a problem, the first thing you want to do is to eliminate any denominators, multiplying by the LCD or lowest common denominator. You want to simplify the left side and the right side as much as you possibly can. That is, go ahead and clear any parentheses using distribution, combine like terms, put variable terms together and constant terms together. Then you want to make sure your variables are all on one side. You can add or subtract the variables across the equal sign to do that, but you will want to get them all on one side. Then you get the constants on the other side, again by adding or subtracting. You would then end up solving for the variable by either multiplication or division and check your answer. So these are the 6 main steps that we use when solving equations, and hopefully you found it helpful. I do have another worksheet with 6 problems with fractions on it. If I get time, I'll throw a quick video of that out there. It's just a optional alternate video. All right. The assignment is graded. It is on WebAssign. I believe it is called Math with Business Apps, section 5.1. If you have any questions or concerns, please don't hesitate to reach out to myself, the support personnel, or the Math Center. We are all here to help you and have times available. Thank you.